Okay, Algebra 2s, let's review Unit 2 dash, now this is supposed to be a 4, where we talk about solving quadratic equations by factoring. So what we're going to do for each of these quadratics, this power of 2, means that there's two potential answers. So when we go to solve it, we set the entire equation equal to 0, because we're looking for where is this output equal to 0? Where does it touch or cross the axis? Now keep in mind, we have three different scenarios. We could have 0 solutions where it never touches, 1 where it sits right on, or 2 where it crosses. And this is why we've been factoring, because what we're going to do is break down each one, set it equal to 0, and then solve for x. So we did 2 examples in class, but I want to finish the notes by doing the second ones. Notice what's different now is that my equation is set equal to 0. But when I start, I'm going to still be thinking about how do I go ahead and factor this? I'm going to take a 2 out of each of these because, again, my GCF is going to be where I'm starting to look. Now, these numbers here are very familiar to me. That's a perfect square, that's a perfect square, which means I am looking at the difference of squares. So I'm going to set that up in the same way I always do. The square root of my first term, the square root of my second term, and then opposite signs. It factors into the sum difference pattern. So this is where we used to be finished. We'll move on to the next question, but now we have this is equal to 0. So what I'm going to do is solve for 0. Now here's the weird part. If this is just a constant, no variable, I can go ahead and just divide and not worry about that anymore. Every expression that has an x, I'm going to take the time and I'm going to set it equal to 0. So I have 2x plus 5 is equal to 0. 2x minus 5 is equal to 0. The reason why I need to split these is if either one of these has a value of 0, I have found an answer. And what you're going to notice is I do get 2 different answers. X can be negative 5 halves, or x can be positive 5 halves. So these are the 2 solutions. These are the values for the variable that make this equation true, which means that's where my output is equal to 0. So these are my zeros. All right, so I have a quadratic, and what I'm going to do this time is I'm going to switch it around to an order that makes sense to me. But guess what? See this pesky negative 1? I can divide it out and make it so that my signs, my leading coefficient is positive. Just like I did before, I'm not going to worry about this negative 1 because it's a coefficient and no variable. I can divide. 0 divided by anything is still 0. So now I'm looking at is a quadratic trinomial that I can factor. I'm looking for a way to break it down into its multiplied parts. That way I can use my zero product property. All right, 2 numbers that multiply together to give me a negative. One has to be positive, one has to be negative. And we can do our T-chart with 30, 1 and 30, 2 and 15, 3 and 10, 5 and 6. There's my wraparound. So I'm looking for 2 numbers that multiply together to be a negative. One's going to be positive, one's going to be negative, and have a difference of 1. Here they are. Here's my difference of 1. And now I need to decide which one's going to be negative and which one's going to be positive. I need more negatives because my sum was negative. So I'm good to go. All right. Here's where I find my answers. X can be negative 5. Here's my second set of answers. X minus 6 could be equal to 0. X could be equal to 6. These are my solutions. The solutions to your quadratic equation are the x-intercepts. That's where the graph crosses the x-axis. This makes sense because, now think about this, I'm looking for an output equal to 0. When we think about an input that gives me an output of 0, that's what I'm looking for. These x's here. So I take my equation, y is equal to ax squared plus bx plus c, whatever quadratic I have, and guess what I'm going to do? I'm going to set it equal to 0 because I'm looking for where is the output 0. Where does it cross that axis? Make sense? All right, let's do some practice. Let's flip over and look at the back of the notes. The back of the notes talk about the standard form of a quadratic equation. We have a and b and c are going to be our coefficients to our squared and our linear and our constant term. When a quadratic function is in standard form, we need to factor to find the x-intercepts or the zeros of the function. We want to rewrite this equation into intercept form, and the p's and q's are whatever constant make this number sentence or this number puzzle true. When a quadratic equation is in intercept form, we know the intercepts or the zeros. So if we're asked to find the zeros, remember this word also means x-intercept, and it also means our solutions. Guess what? Sometimes we call it the roots. So this one term means all of these things too. I take my quadratic equation and I set it equal to 0. And then what I want to do is break down my quadratic trinomial into its binomial factors. 8 plus 5, or x plus 5, x plus 3. 5 times 3 is 15. 5x and 3x is 8x. So I know I've unfoiled. Now I have my two little mini equations. Because what this is telling me is x could have a value of -5, or x could have a value of -3. Check it out. There they are. Here is where x is equal to -1, 2, 3, 4, 5. This ordered pair and this ordered pair are our intercepts. That's where the graph crosses the x-axis. Okay. We can go ahead and substitute these answers into our equation. -5 squared plus 8 times -5 plus 15. -3 squared plus 8 times -3 plus 15. And we can see why they're called the zeros. Our output is equal to 25 plus, that's -40 plus 15. So we can go ahead and grab our calculator and we can say, okay, 25 plus -40 plus +15. No surprise, that's going to give me an output equal to 0. This input gave me an output of equal to 0. But guess what? So does this one. Y is equal to 9 minus 24 plus 15. We'll go ahead and add that up again. 9 minus 24 plus 15. And guess what? We have another 0. Our job is to figure out where this graph crosses the x-axis to find these two solutions. So our number one way of doing that is by factoring. So for each of these, we're going to go ahead and say, all right, I'm looking for the 0. I'm looking for an output of 0. Here's a quadratic trinomial, and I'm going to look at how do I factor that. What two numbers multiply together to give me -6 and add together to give you -1. If you want to think about the factors of 6, 1 and 6, 2 and 3, here's our wraparound. So a -3 and a +2 are going to be our numbers that solve this number puzzle. My 3 is negative because I have more negatives. I used to be finished here, but now I need to go one step further and split my equation and find each of these values for x. X can have a value of positive 3. X can have a value of negative 2. These are my answers, my roots, my zeros, my solutions. All right, let's do another. I want to figure out where this equals 0. So let's go ahead and factor x and x, make x squared. Two numbers that multiply together to give me 12, add together to give me 7. When I look at my factors of 12, 1 and 12, 2 and 6, 3 and 4, here's my wraparound. I like 3 and 4. I'm not done, because what I now have to do is solve for x. And this is the only new part. That's the only new part. X is equal to negative 3, and x is equal to negative 4. Those are my answers. Somebody says, hey, where does this graph cross the x-axis? Here you go. At x is equal to negative 3, and x is equal to negative 4. All right. Check out this one. It's a special pattern. I know it's a special pattern because it's two terms, so I'm curious. And guess what? This is a perfect square, and so is this. So here is my difference of two perfect squares. I'm going to set them equal to 0 and factor. X plus 2, x minus 2. Here's one little mini equation, and here's another little mini equation. X can be equal to negative 2, and x can be equal to positive 2. There's my answers. All right, so maybe this is a little tricky for you. So guess what? We're going to bring in our magic number. So we've had one special pattern. We've had one where the signs match, one where the signs are different. And notice we're just going to give you samples of each one and have you practice, practice, practice. So our magic number is equal to 8. I'm looking for two numbers that multiply together to give you 8 and add together to give you negative 9. Did you get it? Now these aren't our factors because we're doing magic number. So what they are the two terms I'm going to use to rewrite my middle term. Instead of negative 9x, I'm going to say minus 1x and minus 8x. Now I have four terms, 1, 2, 3, 4. So guess what I can do? Da-da-da-da-da. Associative property. Able to divide and group things any way I want. So we'll go ahead and pull out just an x here. Just my x comes out, leaving me with 2x minus 1. I think I'll pull out a negative 4 here, and that's going to leave me with positive 2x minus 1. There's my happy face. So 0 is equal to 2x minus 1, and what's left behind? Guess what? Not done, because I brought this 0 down with me the whole way. So 2x minus 1 could be equal to 0, but so could x minus 4. X is equal to 4. Add 1 to each side, divide by 2. So x is going to be equal to 1/2. So here we have our two answers. All right. Next up, the homework.